Ladies and gentlemen, welcome to the 3rd Korea-Indonesia Offshore Congress. My name is Leah Atmajaya and I will be your MC for this afternoon. We appreciate your attendance at this conference today. We will begin once all our VIPs enter the hall. Please be seated. Ladies and gentlemen, now Mr. Song Myung-dal, Deputy Minister of Marine Policy Office, Ministry of Oceans and Fisheries, Republic of Korea. Mr. Nanang Widyatmojo, Assistant Deputy of Navigation and Maritime Safety, Coordinating Ministry for Maritime Affairs and Investment, Republic of Indonesia. Professor Dr. Oh Jin-suk, Professor of Korea Maritime and Ocean University, and Mr. Nanang Abdul Manaf, Vice Chairman SK Kamigas, Republic of Indonesia, are entering the hall. Please welcome our VIPs with a big round of applause. Good afternoon, ladies and gentlemen. Once again, I am Leah Atmajaya, your MC for the 3rd Korea-Indonesia Offshore Congress. We appreciate your attendance at this conference today. The 3rd Korea-Indonesia Offshore Congress aims to facilitate and enhance cooperation between the Republic of Indonesia and Republic of Korea in the offshore and maritime service sectors. Through B2B MOU signings and conferences, we aim to promote G2G and B2B partnerships that will benefit both countries. We strive to provide a platform for Korean companies specializing in offshore plant services to showcase their products and services, and for promising companies to connect with potential Indonesian business partners. Our goal is to foster collaboration and create new opportunities for growth and success in the industry. Before we begin, let me inform you of today's programs. There will be opening remarks, welcoming remarks, congratulatory remarks, and B2B MOU signing ceremony before the conference. During the conference, we will have 3 sessions with 10 distinguished speakers' presentations. Before we begin with today's agenda, I would like to announce the arrival of our guest of honor for today, Mr. Song Myung-dal, Deputy Minister of Marine Policy Office of Ministry of Oceans and Fisheries, Republic of Korea. Mr. Nanang Widyatmoko, Assistant Deputy of Navigation and Maritime Safety, Coordinating Ministry of Maritime Affairs and Investments, Republic of Indonesia. Professor Dr. Oh Jin-suk, Professor of Korea Maritime and Ocean University. Mr. Mustafid Gunawan, Director of Oil and Gas Program Development, Ministry of Energy and Mineral Resources, Republic of Indonesia. And Mr. Nanang Abdul Manaf, Vice Chairman SK Kamigas, Republic of Indonesia. Thank you again for your presence here today. And now, to officially begin the conference, Professor Dr. Oh Jin-suk, Professor of Korea Maritime and Ocean University, will deliver his opening remarks. Professor Dr. Oh Jin-suk, please come up to the stage. Ladies and gentlemen, please welcome Professor Dr. Oh Jin-suk with a warm round of applause.
Hello, dear and respectable ladies and gentlemen. I am Professor Jin-suk Oh of Korea Maritime and Ocean University, and in charge of offshore plant cooperation project between Korea and Indonesia. Now, I would like to express my sincere appreciation for attending the 3rd Korea and Indonesia Offshore Congress, hosted by the Minister of Maritime Affairs and Fisheries of Korea, and organized by Korea and Indonesia Offshore Plant Cooperation Center. I want to thank you, Mr. Myung-dal Song, Director of Ministry of Maritime Affairs and Fisheries of Korea, who came one step despite the long distance. And Nanang Widya Mojo, the name is very different. Assistant Deputy of Navigation and Maritime Safety of Indonesia, who generously support the event. Please give them a round of applause. Thank you. I would like to thank you, the distinguished guests from Korea and Indonesia. This event is already celebrating its third, starting with the first event in 2020. In the meantime, Korea and Indonesia have a continued cooperation in the offshore plant service industry. In particularly, in 2021, we signed an MOU for collaboration with the offshore plant service industry. And in 2022, we successfully carried out a pilot project for offshore plant dismantling. Also, today, the first offshore plant service industry joint committee meeting was held. These achievements are attributed to generous support of Korean and Indonesian government and companies will in both countries. Korea and Indonesia have a different resource and industrial structures. On the other hand, despite of conventional resource and environmental concerns drive the demand for renewable energy. Accordingly, we need for maritime energy generation is also increasing. Korea has advanced technology and expertise in offshore plants, and Indonesia possesses numerous natural resources thanks to its geographical condition. As such, Korea and Indonesia have their strengths, so mutually beneficial results can be obtained through cooperation. Therefore, Korea and Indonesia need to cooperate to combine high technology and natural resource to seek new development possibility in field of offshore plant and promote sustainable development. I hope today's event will trigger active technology and people-to-people exchange while forming or developing relationship between Korea and Indonesia. Our Korea-Indonesia Offshore Plant Cooperation Center, you will remember these centers, okay? Will do its best to develop and maintain a mutually beneficial relationship between Korea and Indonesia. Finally, ladies and gentlemen, let us always have a sense of duty to create a development joint model for Korea and Indonesia. Once again, thanks so much to everyone who joined us today, and I wish you happiness and glory in the future. Terima kasih. Thank you. 감사합니다.
Thank you, Professor Dr. Oh Jin-suk. You may now return to your seat. Next, on behalf of Mr. Jody Mahardi, Deputy Minister for Maritime Sovereignty and Energy of the Coordinating Ministry for Maritime Affairs and Investment, Republic of Indonesia, is Mr. Nanang Widyatmojo, Assistant Deputy of Navigation and Maritime Safety, will deliver the welcoming remarks. Please give a round of applause.
My honorable guests from the Republic of Korea, His Excellency, Deputy Minister for Marine Policy Office, Ministry of Ocean and Fisheries of the Republic of Korea, Mr. Song Yong-dang, colleagues representing the various government and business agencies in Korea, fellow colleagues from the Republic of Indonesia, His Excellency Director General of Oil and Gas, Ministry of Energy and Mineral Resources, Mr. Tutuka Aryaji. Oh, okay. Chief Head Special Task Force for Upstream Oil and Gas Business Activity, SKK Migas, Mr. Nanang Abdul Manaf, and participants from various government and business agencies in Indonesia. Excellencies, ladies and gentlemen, good afternoon, everyone. Welcome to the third Korea-Indonesia Offshore Congress. Representing the government of Indonesia, I once again extend our welcome to our colleagues and friends from the Republic of Korea and the Republic of Indonesia. I apologize that Deputy Jody could not welcome you in person as originally scheduled. Mr. Deputy Jody sent his warm regards and appreciated your attendance to the meeting. Excellency, ladies and gentlemen, this year marked the 5th anniversary of diplomatic relations between Indonesia and the Republic of Korea. Today, Indonesia and the Republic of Korea are more than close friends. We are special strategic partners. Trade between Indonesia and the Republic of Korea, as well as strong people to people, cultural and business links, have delivered significant benefit to both our countries. Excellency, ladies and gentlemen, just this morning, we hear the official report that we had completed the pilot project on decommissioning and rig-to-reef reutilization of offshore plant in Indonesia. The pilot project was conducted on Ataka EB platform. Located in Ataka Oil and Gas Field, East Kalimantan. This pilot project is a breakthrough in Indonesia upstream oil and gas industry, which can later become a reference for decommissioning project in the future, in terms of planning, licensing, engineering to implementation. Let me congratulate the government of Indonesia and the Republic of Korea for this accomplishment, especially for the Korean government, which are willing to support and expand the budget for research and marine environmental purpose, and also all Indonesian officers who are willing to put their effort and time to expedite this project. Following that achievement, we still have homework to dismantle the remaining over 100 oil and gas platforms in Indonesia water, which are currently in the post-operation stage. It is my understanding that the jurisdiction of the international legal regime of the sea does not apply to such structure situated within a state territorial waters. However, the principle is this: any installation and structure which are abandoned or discharged must be either partially or entirely removed. On another note, as assets of the state, this platform represents quite a significant value in our books. We also have to consider the large amount of funding that will be required for their decommissioning. There is currently no specific fund allocated in our budget for the removal of the platform installed prior to 1994. On this, we seek to cooperate with all parties, public or private, inside or outside of Indonesia, who are willing to collaborate and work on solution to this affair. Colleagues, ladies and gentlemen, Indonesia and the Republic of Korea have been working closely as partners over the last 50 years. Today, I am delighted that we are bringing our relationship to another level and stepping forward through the MOUs that we have just concluded to widen the economic collaboration between our private sector. It will also unlock new possibilities for business to drive their growth in the green economy and position our offshore plant services industries to grow domestically, regionally, and globally. It is my pleasure to join you this afternoon to witness the signing MOU as we look forward to the exciting opportunities ahead. I would like to invite interested parties to contact us in the coordinating ministry with purpose related to coordination with the relevant stakeholder in Indonesia on this matter. Colleagues, ladies and gentlemen, once again, thank you very much for attending this Congress, especially my honorable guest, the Deputy Minister who flew a long way from Korea to Jakarta to attend this event. And thank you very much to all participants at this meeting. Thank you.
Thank you, Mr. Nanang Widiatmojo. Next, it is my great honor to introduce to you Mr. Song Myong-da, Deputy Minister of Marine Policy Office of the Ministry of Oceans and Fisheries, Republic of Korea, who will deliver his congratulatory remarks. Ladies and gentlemen, please welcome Mr. Song Myong-da.
Good afternoon. Selamat siang. I'm Song Myong-da, Deputy Minister for the Korean Ministry of Oceans and Fisheries. I would like to express my gratitude to all the guests, especially Mr. Nanang Widiatmojo, Assistant Deputy of Navigation and Maritime Safety, who took the time to attend this third Korea-Indonesia Off-Shore Congress. This year marks the 50th anniversary of diplomatic relations between Korea and Indonesia. Over the decades, Indonesia has become an important and very special strategic partner of Korea. In the field of maritime cooperation, we have been able to establish varying relationships and cooperation. On top of signing the MOU on maritime cooperation in 2016, we have also managed to open an offshore plant cooperation center and sign another MOU on cooperation in the offshore plant service industry. Based on this maritime cooperation between the two countries, we successfully completed a joint project last year to decommission and reuse an aging offshore platform here in Indonesia. Despite unexpected difficulties such as the COVID-19 pandemic, both governments and related companies put forth considerable effort toward achieving the common goal of successfully completing this pilot project. As a result of these efforts, we achieved a significant accomplishment, which was Indonesia's first dismantling activity of an aging offshore plant, and we are pleased to celebrate this achievement with all of you, including Mr. Nanang Widyamojo, Assistant Deputy of Navigation and Maritime Safety. Indonesia is the largest oil producing country in Southeast Asia with over 600 offshore plants, and the industry's ability to maintain and replace equipment to support these plants is as important as ever. In addition to this existing industry, Indonesia is also exploring eco-friendly transitions from existing carbon-emitting industries to reduce greenhouse gases worldwide. Accordingly, there is a forecasted industry demand for the construction of marine infrastructure such as FSRUs, FGPPs, and LNG bunkering to convert existing oil and gas production facilities and diesel power plants to renewable energy or on environmentally friendly fuel production facilities. Korea possesses world-class technology in shipbuilding, marine plant construction and equipment, and service technology. The technology that we have and can develop will make us the best partner for Indonesia to accommodate all its oil and gas production facilities. Our technology can also support in realizing the blueprint for energy transformation that is currently being drawn. The strong cooperation between the two governments over the past 50 years has laid the foundation for both countries' companies to excel in new markets. Together with today's third Korea-Indonesia Offshore Congress, I believe it will serve as a cornerstone for true cooperation between the two countries, leading to business success. Lastly, I would like to thank all the distinguished guests who have illuminated this occasion. We all continue to cooperate with the Indonesian government to support the development of both countries' companies in the field of offshore plant services. Thank you. Terima kasih.
Thank you so much, Mr. Song Myong-da, for your meaningful message. And now, ladies and gentlemen, we will begin the B2B MOU signing ceremony. We will have 2 sessions of the ceremony accordingly. We will witness some esteemed Korean and Indonesian offshore service companies sign MOUs to symbolize their cooperation for potential future collaborations. The companies who are signing the MOUs today have the goal to create an environment of collaboration between Korea and Indonesia and are eager to implement their visions with the current market trends in Indonesia. The MOUs range from cooperation and collaboration in decommissioning, the development of business-related engineering solutions, EPC partnerships, LNG infrastructure development, and contributions to human resource development. The companies have been in discussion of potential collaborations for certain promising projects. On top of private projects, it is also hoped that Korean companies can support Indonesia in fulfilling its goals to transition to sustainable energy sources and also to help realize the various other strategies and roadmaps established for Indonesia over the years to come. Collaborations such as this can not only increase investments in Indonesian development, but also open new roads for Korean companies to participate in local tenders, increase business presence in Indonesia and Southeast Asia, expand their network in a new market, and even open representative offices in Indonesia for smoother operations. To begin the signing ceremony, I would like to invite our first group of signees who plan to collaborate further in platform decommissioning and other aspects in this field. Once the names are called, please move up to the stage and be seated. First, we have BMI and PT Bina Reka Cipta Utama. This MOU has the objective to develop business-related engineering solutions, such as engineering designs for offshore projects. For BMI, we have CEO, Mr. Yi Gyong Choi. From PT Bina Reka Cipta Utama, we have President Director, Mr. Andang Sentano. Please come up to the stage. Second, we have Khan and PT El Nusa. Their MOU aims to cooperate and collaborate in the development of offshore service industry projects. From Khan, we have the CEO, Mr. Jang Hwan Hyun. PT El Nusa will be represented by Mr. John Hisar Simamora, President Director. Third, we have Hyundai Heavy Industries and PT Tima Suplindo signing their MOU. They hope to create strategic partnership arrangements to cooperate in the areas of EPC, transportations, installation, and demolition of offshore oil and gas facilities. From Hyundai Heavy Industries, we have the Senior Executive Vice President of Shipbuilding and Offshore Business Unit, Mr. Kim Jaeol. From Timas, we have the Vice President of Operations Offshore Division, Mr. Tiopan. Signees, without further ado, please sign your MOUs at the bottom of the document. And now, the signees, please exchange your MOUs with your signing partners. Please sign at the bottom of the documents. Thank you to our first batch of signees, BMI, PT Bina Reka Cipta Utama, Khan, PT El Nusa, Hyundai Heavy Industries, and Timas. Ladies and gentlemen, please give a round of applause for the signees. Distinguished signees, please kindly stand up and wait on stage. Bring your MOUs. We will wait for the others to finish the signing ceremony, and then we will have the commemorative photo session all together after the signing ceremony. Next, we will have our second batch of companies approach the stage. Once the names are called, please move up to the stage and be seated. For the first batch, we have Newgen INS, Information and Services, and Polytechnic Ilmu Pelayaran Makassar signing their MOU. This MOU aims to develop LNG training simulators to contribute to developing trained seafarers and maritime manpower in the field. For Newgen INS, we have Mr. Sang Kyu Park, President Director. For PIP Makassar, we have the Director, Captain Sukirno. Second, we have LNG Korea Consortium and PT Jaya Samudra Karunia Gas. These parties are signing in hopes of increasing projects in LNG infrastructure development. To represent LNG Korea Consortium, we will have CEO Mr. Yi Jae-hyun. For PT Jaya Samudra Karunia Gas, we have CEO Mr. Jang Sang-kyu. Third, we have Gas Entech and PT PAL Indonesia. Their MOU focuses on the collaboration for LNG solutions, mainly on LNG carriers, LNG FSRUs, and other LNG infrastructure. To sign for Gas Entech, we have Mr. Chang Ho Kwak, CEO. And for PT PAL Indonesia, let us welcome the Director of Production, Mr. Iqbal Fikri. And last but not least, we have Trans Gas Solution and PT Pelayaran Korindo. Their cooperation focuses on LNG bunkering hub construction, such as LNG carrier to FSRU conversion, FLPC, and SSLNG, and aims to build new technology to contribute to the field. For Transgas Solution, we have CEO Mr. Yi Jae-ik. For PT Pelayaran Korindo, please welcome Vice President Mr. Jo Myung-kook. Signees, please take a seat at your designated chairs. And now, without further ado, may the parties sign their MOUs at the bottom of the document. Now, please exchange your MOUs to your signing partners. And now, the signing partners, please sign at the bottom of the documents. Thank you to our last batch of signees, Newgen, INS, PIP Makassar, LNG Korea Consortium, PT Jaya Samudra Karunia Gas, Gas and Tech, PT PAL Indonesia, Transgas Solution, PT Pelayaran Korindo. Ladies and gentlemen, please give our signees another big round of applause. And now, please allow us to have a commemorative photo session with all the signees and all the representatives together. Please, signees, stand up, bring your MOUs and stand in front of the table. In front of the stage, please. We will have a photo session with you opening your MOU. Please be careful when you show your MOUs. Don't let the papers fall. And now we are also inviting Mr. Song Myung-dal, Deputy Minister of Ministry of Oceans and Fisheries, Republic of Korea, and Mr. Nanang Widyatmojo, Assistant Deputy of Navigation and Maritime Safety of Coordinating Ministry for Maritime Affairs and Investments, Republic of Indonesia, to join this photo session all together. Gentlemen on the stage, please be careful when you open your MOUs. Please hold the paper, stand still. We don't want that to fall. Let's take a group photo. Satu, dua, tiga. Nah, set. Thank you so much. Thank you for MOU signing parties. May your respective collaborating bring fruitful outcomes. Can we please give them a big round of applause, everyone. Thank you to all the representatives and also Mr. Song Myung-dal and Mr. Nanang Widyatmoko. You may now return to your seat. Thank you so much. Once again, ladies and gentlemen, please give them a big round of applause for Indonesia and Korea collaboration. We are about to begin the third Korea-Indonesia Offshore Congress. On the Congress, we will have 3 sessions of different topics and distinguished speakers will deliver their presentations. The 3 sessions on the offshore industry in Indonesia cover topics such as energy transition policymaking, offshore decommissioning, and reutilization of aging offshore platforms, and the development of energy transition infrastructure. Our first session will begin now under the title of Navigating the Offshore Industry in Indonesia, Insights into Energy Transition Policy Making. May I introduce to you our speakers of the first session. Please welcome them with a big round of applause. Mr. Mustafid Gunawan, Director of Oil and Gas Program Development, Ministry of Energy and Mineral Resources, the Republic of Indonesia. Mr. Nanang Abdul Manaf, Vice Chairman of SKK Migas, Republic of Indonesia. Mr. Miftahul Huda, Director of Marine Services of Director General of Marine Spatial Management of Ministry of Marine Affairs and Fisheries, Republic of Indonesia. Speakers, please be seated. Pointer is available on the podium for you to use for your presentation. Let us begin the first session with Mr. Mustafid Gunawan, Director of Oil and Gas Program Development, Ministry of Energy and Mineral Resources, Republic of Indonesia, to move to the podium for your presentation. Ladies and gentlemen, please welcome Mr. Mustafid Gunawan.
Thank you very much. Good afternoon, ladies and gentlemen. First of all, I will like to convey apology from Mr. Tutuka because he has another agenda, so he cannot join with us in this afternoon. So he asked me to deliver the material of presentation with the topic of implementation of LNG supply infrastructure and fuel conversion in power plants in Indonesia. This is Minister Decree number 249. Next, please. Okay. So for the material from the outline, so we have eight points. The first is about the natural gas optimization as energy transition, and the second, Indonesia gas balance 2023-2032, Indonesia energy balance 2023-2032, and the fourth is Indonesia gas governance. The fifth, the background of fuel to gas conversion program. The sixth, power plant gasification project, and distribution of location and volume of LNG gasification in Minister Energy and Mineral Resources decision number 249 year 2022. Okay, next please. Yeah. So, ladies and gentlemen, from this slide, that's about the natural gas optimization as energy transition in Indonesia. Natural gas has become our alternative energy source because this is insufficient in quantity and is relatively environmentally friendly. So there is three aspects. One, the first about energy security. We know that in Indonesia we have declining producing for the oil. In the other hand, that the consumption of fuel oil is increased. So we have to import the fuel oil. And the second, from the energy security, we have to try to utilize the alternative oil energy. So that's why this is, we try to monetize from the other alternative energy from the gas, natural gas. And the second is abundance. We know that Indonesia has many field gas, and we produce gas quite big. And for your information, that currently from the domestic consumption is about 68% gas, and the other is for the export. And the third is lower emission. I think everybody knows that gas is quite good. Is for the emission is a half of a coal. Next, please. So from this slide, you know that this is to side from supply and demand. For the demand that we have categorized for the blue color is contracted demand, for the orange color is committed demand, and the green color is potential demand. For the categories is we can see that the contracting demand its mean is the cash demand based on the existing gas sales and purchase agreement, and we see that time by time from 2023 is decreased, and the orange color from the cumulative demand we see that increase by year, and from the potential demand we can see as additional demand until 2032 is quite stable around 6,000. From the supply side, with the black line, this is existing supply. It means that the supplies come from the producing field, and this is existing for currently. And the red color, this is talking about the project supply. This is a gap from the existing supply and project supply. If the projects are on stream, so the graphic of red line is become executed, and the blue line is talking about the potential supply. In this category include the exploration that we hope that in the next future become part of additional supply for the gas for the domestic and export. Next, please. This slide show about the LNG balance year 2023 to 2032. We see that from 2023 to 2035, it looks like for the contractual is decrease, because this is our policy from the government. We put the priority for fulfilling the domestic market first. And we see that from the uncommitted cargo, this is we have a gap from the producing and the uncommitted cargo that we need to market the LNG. We try to create the demand in domestic and of course to export. Next, please. This is about the Indonesia gas governance. This is a 3 point important that first, that natural gas as a non-renewable natural resources and need to be regulated wisely by government. And the second is about the energy security and independency of the greatest prosperity of the people. And the third is the use of natural gas is priorities for the domestic use. So as we can see then the picture, supply, infrastructure, demand, and price. For the first, talking about the supply is guaranteed by government, and government try to increase the supply coming from the accelerating natural gas field project, increasing exploration, activity, and so on. And the second is about the integrated infrastructure development. This is, we try to make infrastructure for the natural gas in line with the demand needs. And the third, about the optimize of the utilization. So this is we have many programs such as power plant gasification program, support special economic zones or industrial zones, city gas network, and so on. And the fourth is fair pricing. So this is also regulated by the government. Next, please. For the program of fuel to gas conversion program is a background first about the economic condition in 2019. We know that the trade balance in 2019, we have a deficit due to the high fuel import. The second is about the high fuel consumption and power supply prime cost occur. So by President direction, we have 2 points. The first, we have to make a gasification in electricity by PT PLN, and the second, to substitute marine vessel power using using gas. So we have already follow-up for this program. First, our Minister Energy and Mineral Resources decree released the Capman number 249. This is to accelerate the program diesel to gas for the power. Next, please. For the program power plant gasification project, this program will be able to fulfill various aspects. There are X aspects. For the first, reducing fuel import to save foreign exchange. The second, optimizing the use gas for the domestic. The third, meeting energy mix target in national energy policy. The fourth is talking about reducing the subsidy. Fifth, making more competitive national electricity for the price. The seven is reducing carbon emission and meeting the commitment of Paris Agreement. And the last is contributing for value added and multiplier effect to the local people's economy. Next, please. From this slide, we try to make some mapping about the location and fulfillment LNG gasification in Minister Energy Mineral Resources Decision number 249. This is from Papua, and then to most of this is in eastern part of Indonesia. Totally, there are 47 locations, and with gas almost 283 mmSCFD. Next, I think this our presentation delivered by Director General in Oil and Gas. Thank you very much.
Thank you, Mr. Mustafik Gunawan. Next, let us invite Mr. Nanang Abdul Manaf, Vice Chairman of SKK Migas, who will be speaking on the topic of policy and strategy in decommissioning and reutilization of aging offshore platform. Ladies and gentlemen, please welcome Mr. Nanang Abdul Manaf with a big round of applause.
Thank you. His Excellencies, Deputy Minister for Marine Policy Office, Mr. Song Myong Dao, and the Honorable Chairman KMOUC, Mr. Oh Jin Siok, Yang terhormat Asisten Deputy Navigation and Safety, Pak Nanang Widiatmoko, and distinguished guests, ladies and gentlemen. First of all, we would like to thank for inviting us in this session, and I would like to share several issues regarding the policies, and then strategy decommissioning and reutilization of aging offshore. And these are the main outline. Okay, I would like to share decision opening with the Indonesian oil and gas 4.0. We call the IOG 4.0, and then followed by the decommissioning program. And of course, we would like to share about our challenge in Indonesia and the national decommissioning program. We would like to update the progress and platform population in Indonesia. Safety practice for platform decommissioning activities, platform reutilization alternative, future decommissioning project. So let's start in this my presentation to highlight Indonesia Oil and Gas IOG 4.0 program, which comprises a new long-term strategic to support our bigger achievement for SKK Migas and Indonesia oil and gas sector. Three main aspirations of Indonesia upstream sector, namely turning potential into the result to achieve the best production oil and gas level. And then secondly, to ensure environmentally sustainability through decommissioning program, and of course to support national capability. This is our grand strategy, built by the SKK Migas and team, and to be the national our oil and gas sector strategy, with represented by this diagram, where there are 6 main pillars to support our aspiration, especially by 2030. Decommissioning program will become pillar number 6 on our IOG 4.0 in order to driving efficient and collaborative decommissioning. The oil and gas upstream sector grand strategy in the implementation level have been divided into the 22 key programs, where national decommissioning program have been part of them, with the target to build national decommissioning strategy. Several challenges that we are facing now, how to implement decommissioning program, such as availability, abandonment, and site restoration. Restoration Fund, or ESR Fund, is our main challenge, especially for most of unoperated offshore platforms were built on era PSC before 1994. In PSC contract, and that time we didn't recognize the obligation to implement the ESR. Secondly, our challenge is our regulation that should be required more integrated to make decommissioning more effective and efficient program. How to make the alignment between the ministry and then the government entity. And of course, regarding the method and technology in implementation of decommissioning activities, we'll always update in order to get more efficient program. The several activities that have been done and in progress during development of key program number 6A for decommissioning strategy. First, we collected and reviewed all the data related to offshore platform in Indonesia, such as total of offshore platform, the condition, number of wells, and all data can be seen on IOC SKK Migas Integrated Operation Center. Secondly, identify regulation with related to platform decommissioning and build a massive communication with the stakeholder, especially with the regulation holder. I think this is the very, very important, how to align between the government agency, government entity, and then ministry. And the third, perform cost analysis and appraisal for decommissioning costs. And the last, while developing strategy, we do also execution of decommissioning project to gain benchmarking and a lesson learned. This slide to show the population and distribution of platform in Indonesia offshore, and not included FSO, FPU, or MOPU, with the total 635 platform. Operation offshore platform around 512, and then not operated 116 unit, and then already abandoned 7 unit, and total around 635. The biggest platform population are located in the West Java offshore, and then is Kalimantan offshore, as of 55% in offshore in Java, West Java offshore, and then 30% located in Eastern Kalimantan, and other distributed from the Aceh to Papua. From the 116 operated platform, there are 116 platforms need to perform subsurface evaluation for confirming readiness of decommissioning. 9 platforms are ready to be commissioning, 3 units in PHA ONWG, offshore Northwest Java, and then 6 units in Pertamina Hulu, Kalimantan Timur, in offshore is Kalimantan. And also there are 265 wells on 107 platforms that need to permanent P&A of well. For the ASR fund in IMP Malacca Strait and then Kangean Energy Indonesia, K, are available, but still not to be calculated and confirmation due to still insufficient for decommissioning program. This slide, the following slide, will show platform decommissioning process. Started with the assessment of subsurface, well condition, and facility integrity and safety to determine go or no go the commissioning program. This step will be approved by Director General Oil and Gas, and then continue by performing well P&A to secure the hydrocarbon from subsurface. And this step will approved by Minister Energy and Mineral Resources. And then the oiling or hydrocarbon cleaning on facility such as pipeline, piping system, and other process facilities. Asset write-off process approval from the Ministry of the Finance, and then after that, removal of the platform. Current condition and action require about the funding option and further alternative. So for the available fund, so we just execute the commissioning program directly. And if we have no fund, not sufficient fund, so we will perform the best practicable environment option, such as reuse by upstream oil and gas, leave in situ as grants in propose, and then auction on the spot, still in propose, and abandon or rig to reef. The following are several alternative implementation for the platform reutilization, such as rig to reef, the pilot project on Ataka EB with Korean government, thanks to the Korean government, and rig to fish farm plan with the Pertamina Persero, and then Ministry KKP, and then BRIN, rig to CCS, carbon capture and storage, rig to LNG terminal, study by ITS, Institute Teknologi, 10 November Surabaya, and rig to solar power, coordination with the Director General New and Renewable Energy, and then recycle by other industry in situ write-off. And platform decommissioning project in 2030, we have the PSA or NWG in Northwest Java offshore. We call the FFFT platform, PA and FT, and then VST. And operate by Chevron Makassar Rapak, located in Eastern Kalimantan offshore. We call the Weseno and Rapak field. And then by Kangen Energy Indonesia, K. The platform name is PGC number 7. And the update is still evaluation in subsurface. And then finally, I would like to wrap up our presentation to several key takeaways, such as the main challenge for platform decommissioning is no ASR funding available, especially for assets were built PSC before 1994. Several opportunities for unapproved platform reutilization, such as rig to reef, in situ to right, and then other purpose. SKK Migas is very welcome for industry collaboration to create economies of scale and then capture synergies. I think that's all for my presentation. Thank you very much. Annyeonghaseyo, selamat sore.
Thank you, Mr. Nanang Abdul Manaf. You may now return to your seat. Next, ladies and gentlemen, let us invite Mr. Miftahul Huda, Director of Marine Services, Directorate General of Marine Spatial Management of Ministry of Marine Affairs and Fisheries, Republic of Indonesia, who will be speaking on the topic of Indonesian rig to reef policy concept. Please welcome Mr. Miftahul Huda with a big round of applause.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, good afternoon. The Honorable Mr. Song Myung-dal, Deputy Minister of Ocean Policy, the Ministry of Ocean and Fishery, Republic of Korea. Your Excellency, Professor Jin Soo-ok, the Chairman of Korean Maritime and Ocean University. Yang terhormat Bapak Nanang Widiatmoko, Assistant Deputy Navigation and Safety Ministry, Coordinating Ministry of Marine Affairs, Maritime Affairs and Investment. Distinguished guests, ladies and gentlemen. First of all, might be look different, the pictures and the people in front here. So apologize on behalf of my director who cannot attend in this presentation due to have another agenda. So with all due respect, I will present on behalf of him. So the presentation is about, I think it's already mentioned by the previous speaker, Pak Nanang. It's already mentioned about one of the options for decommissioning and then environmental and sustainability, decommissioning itself, efficiency and everything. So this is the picture of decommissioning Indonesia, the platform. We can see the spread of the offshore platform in Indonesia, and it is the hotspot of the platform is in the northern part of Java. As we can see, Indonesia at least home for 600 offshore oil and gas platform. And then from those number, like more than 80% or 3/4 is more like built before 1994 and has the age 20 years old. And like Pak Nanang said, no specific budget, unclear liability, and then lack of legislative guidance and clearance. And from our data that we got from the SKK Migas, 103 platform with contract before 1994 indeed do not have compulsory abandonment and site restoration fund. And then at the end of 2022, we did the pilot project for one of the option, rig to reef. We thought that the approach is considered as the reasonable option due to the reduction costs and the environmental benefit. The pilot project, as already mentioned, from out of 10, it's already planned before. It's already placed in near the conservation area in Bontang, and we think it's still not ideal. It's still a burden, and it's not. Well, we need to find a solve for the rest of the abandoned platform. The pilot project was funded, as we know, by the Korean government. So we now, the Ministry of Marine Affairs and Fisheries, want to give an idea. There is an opportunity, I think, a solution to solve the problem related to the decommissioning. So if we learn from the Gulf of Mexico, from US, the donation concept actually is a promising solution. Here is the little bit of story. The Mineral Management Services, the MMS, or here in Indonesia might be similar with SKK Migas. And then along with other agency, Academy and Petron and everything, they are collaborated and make an agreement with KKP of US, which is the National Marine and Fisheries Services, and they agree that 5 states in Gulf of Mexico, Alabama, Florida, Louisiana, Mississippi, and Texas, they have a plan to include decommissioning oil and gas platform as an artificial reef. Once the oil and gas rig structure proposed and placement site are licensed, the state and the operator negotiate the term of the agreement for a donation from the operator to the state. In most cases, half of the cost benefit the operator goes to the state's artificial reef. We know that is with current regulation, it will not fit for Indonesian. So again, I would like to quote from Pak Nanang presentation. We need to collaborate. We need to find a solution. We have a problem in the near future. So this is we resume from several documents that the benefit is not only for the company. Company will have a benefit from the reduction cost. Just imagine when the option is the platform should bring to the shore, and then we compare if the platform bring to the nearest site from the original platform. In the pilot project, we bring the platform outside of the oil and gas area, which is still not ideal scheme due to the costs and other environmental factors. The cost is still a little bit big, and then we actually still have a promising solution. Like for example, we cut and topple the platform near the original one, which is we call it in situ decommissioning. It will reduce the cost significantly. I believe that. And then the other thing, when we topple the platform in situ, when we lift up the platform in Bontang, the rig jacket is already full by life form. If we have to cut it and then bring, there is opportunity they will die. Just imagine if you just cut and then topple it, and then the marine growth still there, the schooling fish still exists in the original one. So for a little bit jump. So for the marine species, the artificial reef or rig to reef provide habitat, shelter, food, and other elements necessary for a biologically diverse and productive ocean. And then for the environment, carbon offset reduction is now become an issue in worldwide, I think. Just imagine again, when the vessel bring a little bit far and then just move to the rig-to-reef side, it will also reduce not only the cost but the distance. Reduce the distance means reduce the carbon offset. We have some data, and then might be also we have to do some assessment. If we do the in situ option, the carbon offset will bigger than 75 or 80%. If we do something similar to what we have been done in Bontang, the carbon offset is only 14%. So again, to reach this opportunity, we have to collaborate, we have to do synergize with each other. And then the benefit is not only for, again, the benefit is not only for the environment, not only for the company, but also for the state and the local government, as well as the central and the provincial government. The donation concept could be initiate various proposals, develop national, regional, local policy. Like for example, Pak Nanang mentioned about the national plan for decommissioning. It should be in line with a national artificial reef plan. Through KIOR, through intergovernmental agency that we just signed yesterday, we would like to do an assessment how to build the national artificial plan, and then later we'll be in line with your planning, Pak Nanang, and other agency or other ministry, of course. And then, for now, the state-of-art regulation for rig-to-reef, there is no specific national policy. National or local government, as well as the operator, have to make a national decommissioning strategy in a comprehensive way for oil and gas platform in Indonesia, specifically for rig-to-reef option. In the dismantling platform, then further coordination is required with the relevant ministries and institutions. The existing Indonesian government for rig-to-reef now is only two. Government Regulation Number 27, 2021 about the implementation of maritime affairs and fisheries, and the regulation of the Minister of Marine Affairs and Fisheries Number 55, 2021 concerning the study on the conversion of marine building and installation. So in conclusion, we reckon the Ministry of Marine Affairs and Fisheries strategic plan, if we want to adopt the rig-to-reef as an option, so we will do through KIOR, we will start the study of the concept. Further coordination is needed for the rig-to-reef policy to involve related ministers and agencies so that the dismantle of oil and gas platform in the future will bring benefit to the country. Of course, for this, to achieve this goal, we need to collaborate, all the ministry, all the stakeholders, especially from the ministry, the coordinating Ministry of Maritime Affairs and Investment. Thank you very much.
Thank you, Mr. Raden Bambang Aditya Nugraha from the Ministry of Marine Affairs and Fisheries, Republic of Indonesia, speaking on behalf of Mr. Miftahul Huda. Ladies and gentlemen, all speakers for the first session, thank you so much. Ladies and gentlemen, please give them a big round of applause. You may now return to your seats. Thank you. Now let us move on the second session. Our second session will begin under the title of Offshore Decommissioning and Reutilization. May I introduce to you our speakers of the second session. Please welcome them with a big round of applause. Number one, we are calling Mr. Oh Hyun Song, Project Director of Kan Offshore. Also, Professor Dr. Ketut Buddha Artana, ST MSc of Institut Teknologi 10 November. and Dr. Jo Won Dong, Advisor, Carbon Korea. All the speakers, please be seated on the sofa. Let us begin the second session with Mr. Oh Hyun Song on the topic of decommissioning experience in pilot project in Indonesia. Mr. Oh Hyun Song, please move to the podium for your presentation.
안녕하세요. My name is Oh Hyun Song. I just introduced. Before start of the presentation, I'm a Korean, so I cannot speak in English. I can speak in 콩그레스. So in case, how to call Indonesian English? Do you know? I think in English. Indonesian English is in English, so I can speak in Korean. 콩그레스. Okay. Today, that's one. Content is like this: introduce of decommissioning pilot project, project description and marine fleet arrangement. Something is wrong, so 1.8 is I have some summarize. Second is decommissioning process. You can watch the video. And third is the commissioning experience and meaning. Yes. Project description is project name, decommissioning, and legal trip, pilot project. Client is both Indonesian government and Korean government. Contractor is Khan Consortium. We have a 13 company joined this pilot plant. Project period for the offshore decommissioning work, we have a plan total 5 months, including some engineering and then dismantle or decommissioning work, or we have to plan 2 months mobilized offshore campaign. Yeah, firstly, our planning is we have the 2 platform decommissioning, but several reasons we can perform the only 1 platform. This is Ataka EB. Yeah, that is key milestone. I just comparison of the original plan, actual plan. Original plan, we have to, as I mentioned, we have to dismantle or decommissioning of the 2 platform, but we have some reason. This means when we are staying in the bottom, we have some problem for the custom clearance. So we spend a lot of time, 2 weeks. So reduce over our offshore campaign duration. So totally, our plan is offshore campaign is 61 days, but actual date is 78 days plus 18 days is extend. That is also in relating over the cost basis. Next. Yeah, this is permit approval status. Permit is very important to carry out the decommissioning work, but a lot of permit is we have to issued by Indonesian government, but that is also required processing and several duration. So fully sufficiently considering over the permit approval period in Indonesia. Next. Yeah, that is for only information, manpower mobilization status. We are up to 220 people is mobilized on offshore site. Next. Yeah, that is our subcontractor mobilization status, except over the marine fleet HD 2500 and tugboat A1. Other thing is we are mobilized from Indonesia. Look at this table. Next. Yeah, this is marine fleet mobilization. Hyundai booth is open here. We are mobilized HD Hyundai 2500 vessel. And then tugboat is mobilized from Vietnam. Second tugboat mobilized from Elusa. This is Indonesian. Next. Yeah, this is summary of the decommissioning project. First thing is custom clearance. We have to understanding rule and regulation in Indonesia. Then we have to considering of the custom clearance duration or period, because that is also relating of the schedule. We have planned 3 days, but actually we spent 14 days in Batam for the custom clearance. Work permit. Okay, that is also important. What kind of type of permit is required for the decommissioning in Indonesia? We have to understanding, then we have to preparing all the related document properly and also submitted per officer. Then you can get the meeting together a lot of time. Then we can get the permit. This also required 3 or 5 months. Yeah. Third, cabotage. When you are mobilized over the foreign vessel in Indonesia, it's also we have to get a lot of meeting with the Indonesian Ship Association. We call it INSA, because they have to understanding why foreign vessel coming to here, then what kind of work in Indonesia. Properly proceed, then we can proceeding of the decommissioning work. It means for the future, we have to using of the national Indonesia plug vessel in Indonesia. That is more better than mobilize than foreign vessel. Local content, yeah, Indonesia also have to develop. That's why we are most of resource must be mobilized from Indonesia side. It's better than the project period or cost basis have a benefit. Next. Yeah, this is video. Can you watch the please? I think it's more better than understanding of the what is decommissioning work. Okay. This conductor length is over 60 meters. Thank you. Thank you. Next is the decommissioning process. I can explain this step by step, but first step is engineering and site survey. It's very important for the decommissioning engineering. That is core value. It's very important, meaning is maybe very old platform have no any data. When they are installation of the platform, they don't have this kind of file or something. So it's so difficult. Frankly, P&A data also very important, but P&A data we cannot find. In case through site survey, we can find ourselves, plug location or something. Next. Yeah, this one is site survey pictures. Next. Yeah, there is further, we are using of the internal cutting machine. This pressure is almost to 14,000 PSI bar. Next. Yeah, this is preparation work at bottom. Next. This is a towing arrangement route and back to the bottom from side. Yeah, this is anchor plan. Spread mooring. This is topside removal. Topside removal sequence is a pony deck, equipment skid, then conductor. Then we can cut the topside. Yeah, there is cutting cross section for the jacket. This is very important because in the water we can cut below seabed. Yeah, jacket remover. This is the storage plan. This is liquid leaping. Yeah, this is underwater survey using over the ROV. Next. Yeah, last decommissioning achievement and meaning. I said keyword only 3 things. One is Indonesia and Korea have get the experience for the first decommissioning work at offshore. Last thing is securing decommissioning engineering and reference we have. So in the future, we will propose some long-term basis decommissioning plan in Indonesia as SKK Migas required. Okay, thank you.
Thank you, Mr. Oh Hyun Song. You may return to your seat. Next, let us invite Professor Dr. Ketut Budha Artana. He will be speaking on the topic of reutilization of aging offshore platform for LNG infrastructure. Please welcome Professor Dr. Ketut Budha Artana with a big round of applause.
Thank you very much. Good afternoon, His Excellency, Deputy Minister of Ministry of Ocean and Fisheries, distinguished guests, Vice President of Vice Chairman of SKK Migas, Director of Ministry of Energy and Mineral Resources, ladies and gentlemen, my name is Ketut Budha Artana. I'm from ITS Surabaya. The committee invited me to provide you with a presentation on the initial investigation on the reutilization of aging offshore platform for LNG infrastructure. Next, please. Could you help me, please? The next slide, please. The idea come up from the fact that, has been mentioned by Pa Nanang, that currently we have around 600 offshore platform in Indonesian waters, and most of them are Asian platform. And then according to our experience on the project last year, one offshore facility having 52 gas wells and around 2 platforms cost about 120 million rupees for abandonment and site restoration. That's a very huge money. So from that experience, we come up with an idea to find an alternative solution, a more cost-effective solution, and could be a more revenue-generative options, not using for the conventional one, but try to find a new business scheme by utilizing the aging offshore platform. That's the idea. And this result is not the idea of myself, of my laboratory, but after discussing with colleagues from SKK Migas and some oil and gas company. Could you, next please. As I mentioned to you, this is one of the data that we obtained last year, that one offshore facilities cost around $106 million for abandonment and site restoration. Then we want to have a new scheme then. Next, please. And due to the very expensive cost for decommissioning, then some countries tries to find any option to utilize the platform itself. Some of them using for artificial, been mentioned by Mr. O previously, one pilot project in Ataka field. And other countries want to utilize the offshore platform for lighthouse structure, a naval base, and then for the recreation facility. So, but the question is there any possibility to use for a more revenue generative option? Next, please. This picture shows the distribution of offshore platform in Indonesia. More or less 600 offshore platform now in operation, and if we try to correlate between the location of offshore platform and the demand of the energy, then we could see very clear interaction between them. As we can see from this picture, most of the platform located in the West Java, Northwest Java, and then in East Java, and then in East Kalimantan, in which those 3 areas are very, have very high demand on energy. So I think this is one of the hypothesis that if we could utilize the offshore platform as a facility to supply energy to the society, that will be one alternative option, not only to use to decommissioning, but to one option that could provide a new business to us. Next, please. Next, please. I just try to make it sure. And as been also mentioned by Bapak Director, that the government has a rapid plan to distribute energy in Indonesia by means of the natural gas. So in some cases, onshore LNG terminal brings quite many challenges. The first challenge is for sure the high investment required for the onshore-based LNG terminal. The second problem, and might be one of the most difficult problem, is the onshore-based LNG terminal sometimes brings social and cultural issues, social and cultural problems. So by locating the facility far away from the source site, that might be solve the problem. And then terminal LNG will receive quite big vessels. As we well understood, that LNG vessels usually have a very big size. It means we must prepare a proper infrastructure, the shipping channel, the jetty itself, and then the maneuvering basins. Then this will increase the investment, apart from the issues on safety, on environment and land availability. So that's why the idea of reutilization offshore platform into LNG terminal will be interesting. Next, please. This is the picture of a very general concept of transforming an offshore platform into LNG terminal. The idea is by cutting off the top side and then installing the facility for LNG terminal like LNG tanks and a regasification unit. We may keep the existing facility like accommodation, crane, and so on. And whenever we need to reinforce the structure, then we could enforce the structure. And then the LNG shuttle vessel will come frequently to bring LNG to the terminals, and then the offloading could be utilizing the single boomerang as we see in this figure. Next, please. If the size of the offshore platform is not big enough, it's not really big enough, then why don't we try to convert into a regasification terminal? So in this case, then we need one LNG FSU located there to receive the cargo from the shuttle vessels, and then the terminal will be used as the regasification facility. And then if it is the offshore platform, then we may use the existing gas pipeline as the export gas pipeline. Next, please. Allow me to take one case in Indonesia, located in the northwest Java. As we well understood that the gas production capacity there produced by the Pertamina Holy Energy (ONWG) is around 90 million standard cubic feet per day. Whilst at the same time we have quite high demand there. Three big power plants, Muara Karang, Tanjung Priok, and then PLTGU, Jawa Satu, and one fertilizer company is there with the demand of energy around 600 million standard cubic feet per day. Next, please. The government has localized two floating storage regasification units there. The first one is FSRU Muara Karang with a capacity around 200 million standard cubic feet per day. And the other one is FSRU Java Satu with a capacity of 300 million cubic feet per day. It means that the between supply and demand are almost the same. But the problem is, since the production capacity of the facility there is declining, then there is a possibility to add some amount of gas by means of utilizing the existing facility or converting one LNG offshore platform as a terminal LNG over there. So that's the idea. Next, please. In our beginning investigation, we try to look around the 220 offshore platform there, as you can see from this figure. Next, please. And then we need to prioritize to select which terminal could be the candidate for the LNG terminal, and then we implement 7 criteria there. The first one should be quite close to the shore side, and then in the shore side there is a gas infrastructure for distribution, and then platform dimension and capacity will be very much interesting because we need a little big platform, at least the platform with capacity of more than 3,000 deadweight ton. And then whether the platform is active or inactive, whether a standalone platform or a complex platform, and then whether it is oil and platform or gas platform, and then whether we prefer to have a platform with more than 4 legs, and then whenever possible, the water depth is not more than 50 meters. Next, please. By implementing those criteria, then we are come up with the 6 platform, and then the principal dimension of the platform can be seen in the tables below. The water depth is less than 50, and then in average, the age of the platform are around 40 years old. Next, please. Next, please. This is the conceptual of the simple pipeline flow diagram for the LNG terminals. Next, please. And then we try at the initial stage to, list down the facility we need for the terminal, like unloading system, storage system, regasification system, boil-off gas treatment, and so on, and the capacity as well as the quantity of the facility. Next, please. At my laboratory, we start to simulate the existing platform to find the structural integrity of the facilities, just to make sure that technically whether we could use the facility for the LNG terminal, and then if it's not sufficient enough, what kind of reinforcement we need to do to make sure that this facility can be operated. Next, please. And then we consider that the time taken to implement the project is almost around 16 months, around 2 months for dismantling the top side, and then 12 months for fabrication in source side. So that we don't have, we bring the facility in module. So we build the in fabricators in onshore and then bring to the facility by using vessels and then installing on the platform. So in total could be around 16 months. Next, please. Next, please. And then we try to calculate, sorry if the amount is not really representative. We try to calculate the capital expenditure by comparing the LNG platform-based modification, the onshore LNG terminal, and so on. So according to our initial investigation, for 20 million standard cubic feet per day, with the safety stock of 7 days, then the investment we required for LNG platform-based modification is around 42 million US dollars. But if you want to build LNG terminal, onshore LNG terminal, with the same capacity, then the investment could be a bit higher. But this is only the capital expenditure. We don't talk about the any impact by comparing the offshore facilities and onshore facility. Next, please. Floating storage regasification unit rather higher, rather expensive, and then if we compare with the installing one floating storage unit and then we convert the platform as the regasification terminal, then the cost is around 60 million. By comparing these very initiative numbers, then we see hypothetically that converting into LNG terminal is one prospective solution, not in case of the cost of the commissioning, but also we have opportunity to generate revenue by using the facility. Next, please. For sure, this is the initial investigation we had in university. For the investigation would be required the feasibility study to see the technical aspect, economical aspect, especially the regulation aspect, because it's been mentioned by Mr. O that a lot of regulation in Indonesia need to be fulfilled, and then front engineering design as well as the detail engineering design. And ITS will be very keen to work with all colleges. First of all, try to seek the possibility of this, conversion, and I think hopefully one project will be, pilot project will be implemented. Next, please, the last slide. So, in my opinion, if we do market survey analysis this year, I think by fourth quarter in 2025, one facility is ready to be operated. Thank you very much anyway. Looking forward for your discussion. Thank you.
Thank you, Professor Dr. Ketut Buddha Artana. Next, let us invite Dr. Jo Won-dong, who will be speaking of reutilization of aging offshore platform for CCUS infrastructure. Ladies and gentlemen, please welcome Dr. Jo Won-dong with a big round of applause.
Thank you very much. So, before I starting my presentation, I have good news and bad news to tell you before. One, let me start with bad news. I'm not engineers, like many of you in this floor. I'm trained as an economist, and also I'm not a businessman. Although I'm representing the private companies, just Carbon Korea, which is specialized in carbon capture technology. But I'm not an executive. I'm just an advisor. So the good news is that because of economist, I'm a generalist. I can touch on the points which general audience might have more interest. And this is very important for your the market, marketability. And also because I'm just advisor, I'm not advisor. I'm not seeking immediate business opportunity. I can provide more industry-wise or how to say more long-term view of market creation, and that's what I'm going to tell you. And the previous speaker, you heard from previous speakers about for the two application of aging offshore plants. One is linked to artificial lift. The other one is linked to artificial terminal, LNG terminal. So those things are one thing in common, and that's only utilize the offshore platform itself. But they're not talking about depleted well reservoir there, whether it is oil well or gas well. But the topic I'm talking, that I try to talk to you, is that I want to present leak to CCS or CCUS. The CCS create mainly for the depleted gas well. That can create CER, the certified emission right. The CER in the European community in Europe is transacted at more than $100. Even in Korea, it transacted something like $20 or $30 per ton. For the CCUS, mostly for the EOR, enhanced oil recovery, that creates the oil revenue. I'm going to touch on the exact figure, but for the moment, that's it for the depleted oil well. So these are well-known practice already in the United States. There are this EOR, CO2 EOR has been practiced more than since 1970s. So Indonesia used to be oil-producing countries, oil exporting countries. Now you are exporting the gasoline or things like that. The previous speaker in the first round says that even gas potential has been, reservoir is depleting fastly. But so that's not the end of it. You can use depleted oil, oil well, or gas well for the creation of another business. Because although it is the highly value-added business, it obviously they face another very challenges. Next, please. Actually, the holding document which I'm holding is a World Bank report in 2015 that covers, the potential of Indonesian market for CCS or CCUS. It's a very lengthy project. It basically touched upon, singled out three technical difficulties. One is that too expensive to capture cost. Although I'm representing capture cost, that is a very serious problem. I think more than 60% of technical challenges coming from those high capture costs. But I'm afraid that that is not the topic which I'm presenting to you, although I'm representing capture costs. But there are two challenges as well. One is that the average oil well capacity is not sizable enough. The table on the table show that the average the CO2 requirement for the well is something like 10,000 metric ton. 10 million ton. Although, and for the EOR business, so the left-hand side chart shows that the peak demand is only rising something like before 5 years of the operation, and after then, so the demand for oil, demand for EORs, CO2 EOR is decreasing rapidly. This shows that the installment cost for pipeline cannot cover throughout the whole period. That's a challenge. That's a very economical challenge. Next, please. But the World Bank study shows that they recognize the great potentiality of Indonesian market. And that's just that it says that for the oil, I'm quoting from this report. Oil production cost increased only $15 to produce 1 barrel of oil. So if the purchasing price, CO2 purchasing price is something like $40 per ton. So now it's a very oil is very become expensive. When they produce this report, the average oil price per barrel is something like $50 or $60. Now, can you see that more than $80, and it's approaching very highly up to the $100. So great prospect for the EOR market. The previous speaker says that there are only 600 something the offshore plants, but I'm saying that there are more than 700 oil offshore plants in Indonesia. It doesn't really matter. But the point is that you have plenty of opportunity to exercise or take advantage of depleted oil and gas. In the case of Korea, we have only one. It is not an oil well, it is a gas well. Next slide, please. Even though we have only one gas well, we want to use it. We want to experiment our technology on this depleted gas well. Well, we want to use it as a test bed. So once we have a successful, then we might come to you and ask for the collaboration. And that's what I'm talking about. I'm trying to suggest. This particular oil well in the case of East Asia, we call it at East Sea, it's very small. Total amount of the storage capacity is something like 40 million ton. It is easy because you can take out the gas and that can create empty space, right? So it is about 40 metric ton of size. And this were located something like 60 kilometers ahead across the Ulsan area, which is the #1 industrial complex site in Korea. There are a lot of refinery and chemical industries located in that area as well. Next slide, please. And because of a depleted oil gas well, there is a jacket, right? And also pipeline. subsea pipeline. Subsea pipeline is something like 60 kilometers offshore, and the onshore pipeline as well, so 15 kilometers of pipeline. So all located, and then we have a jacket, a platform there. So the first point is how much we can reutilize existing facilities, either subsea pipeline and the jacket. But we have a challenge. One is that in order to use a pipeline, you need to have a very high pressure. You know, CO2 has a very typical, extraordinary property. So if you just cool down CO2 under the ambient pressure, you end up with dry ice, hydrolate. So it can use for the good utilization. Oh, my timing is. So this high pressure is required. Under the Indonesian weather, which is normally something like 30 degrees or so during the year, and then you need more pressure in order to make it critical, supercritical state of CO2. So, whether the first point is that the weather pipeline, which is used for the gas transportation, can withstand high pressure of CO2 transportation. The second thing is that at the top of the injection point, you need to have a decompress pressure. Why? Because of Joule Thomson calling the cooling effect. If you think about air condition, so air condition is the high pressure gas pumped out of the empty space, right? That creates the cooling. Yeah. Now you have the reservoir, which is empty. If you put very high pressure the CO2 into the bore weir, then at the entrance of the reservoir, it's cooled down, and that can make it into dry ice. Dry ice is so hard, the solid state. It can block the well. So how do you do that? Next slide, please. Next. And this is cooling plate, which I'm talking about. Next one. So in order to deal with this cooling effect, you need to depressure, and depressure means that there is heating. You need to heat the liquefied CO2, and then boost it. So apart from the energy to decompression, you have to think about the additional loads on the jacket. If you only get the liquefied CO2, then you need larger the load. If you use the gas CO2 together with the liquefied CO2, then you need a smaller loads. But still, you need to have another loads on the jacket. That creates the problem. The third option is not to use the jacket itself. It's a submersive option. And the thirdly, next one, please. Yeah, this one. So whether a jacket itself, whether a jacket can withstand larger load on the top. And that's very important aspect as well. Next one, please. So if you just rely on the sea pipeline, then the economic benefit is whether how long you can use the pipeline. If you use only 10 years, then sea shipping is much more economical. If you use a longer period, for example, 40 years, then so the black point is even longer, right? But as I said before, Indonesian offshore market, offshore well, is a very small scale and scattered around. So if you use subsea pipeline only, it can, so economically, it may not sound. It may not be sound. Next one, please. So now, there is technology developing, which is using carrier, LNG carrier, and also loading into injection point, which is a submersible one. And it doesn't require any the additional load at the jacket. You see, this is a kind of the variant of option three. Option three, which I talked about earlier. Next slide, please. In the case of Korea, we are experimenting two options. One is a subsea pipeline, as well as sea transportation. The sea transportation coming from Busan area, the CO2 captured at the Busan area, which is going to be transported into the carrier. And the size we are designing is 5,000 ton of CO2, and hopefully it will proven to be successful in 2 years' time or so. And I have to finish with the concept, the carrier, which we are designing. I'm not talking about my company, but sort of a consortium. We are working together. So I have to stop with these slides in your take home study. Thank you very much.
Thank you. Thank you, Dr. Jo Won-dong. I apologize for the tight time we have. Ladies and gentlemen, can we give all the speakers of second session a big round of applause? Before we wrap up second session, let us have a short Q&A session. So if you, the audience, have questions on the speakers, on their presentations, please raise your hand, and the microphone will be delivered to you. Speakers, please stay on stage because we're having a Q&A session, just a short one. Right, audience, do you have any questions? Please raise your hand, and the microphone will be delivered to you. No question? Okay, no questions. Thank you so much once again, all speakers. Can we please give them a big round of applause once again? Thank you. Right. Before we move on to our last session, we will have a 10 minutes break to give you time to visit all the booths behind you. And we will continue the last session at 4 p.m. sharp. So please return to this hall at 5 to 4. Thank you. All right, ladies and gentlemen, we are now begin our third and last session under the title of Development of Energy Transition Infrastructure. May I introduce to you our speakers of the third session. Please welcome them with a big round of applause. Mrs. Kamia Handayani, Executive Vice President of Energy Transition and Sustainable of PLN, Republic of Indonesia. Mr. Ko Jong-soo, Head of Indonesia Branch Office of Kogas Tech. Mr. Surya Triharto, Director of Human Capital and Corporate Services of Pertamina International Shipping. And Mr. Kim Ki-dong, Director of Energy Strategy of Deloitte Consulting. All speakers, please come up to the stage and please be seated. And now, let us begin the last session with Mrs. Kamia Handayani on the topic of PLN strategy and commitment for net zero emissions 2060. Mrs. Kamia Handayani, please move to the podium for your presentation. Please welcome Mrs. Kamia Handayani with a big round of applause.
Thank you very much, and thank you for having me in this opportunity. First of all, I would like to convey the sincere apology from my CEO because he couldn't attend this important meeting because of some another important meeting with the government. So allow me to convey his message in this opportunity. If someone could help with the, okay. So. So PLN is, you may also aware, PLN is an electric utility company. It's a national company. Our operations spread throughout the Indonesian archipelago and also end-to-end business in the electricity sector, starting from generations, transmission, and also distributions of electricity. We are one of the largest utility company having the largest customers in the world, around 65 million of customers, and our last revenue last year is reaching 30 billions of US dollar. Next slide. So we are having the transformations of our company since 2020, and within these transformations, we are aiming to become a sustainable company, a clean power company, and by doing this, we also adopting international standard and also using framework and tools that enable us to running a sustainable businesses. We also assessed by international rating agency. One of it is the World Benchmarking Alliance. So we are put it as one of the 50 most influential electricity company in the world. And we are the top rank out of the electric utility in ASEAN and South Asia. If we can go to the next slide. So under our transformations, we have the commitment to reach net zero emissions by 2060. It was announced, the roadmap was announced during the COP26 in Glasgow by our CEO. So basically, if we are not doing anything under the business as usual scenario, the emissions from the power sector that is being managed by PLN will reach more than 1 billion ton of CO2 emissions. But we don't want to do that path, so we are creating or preparing a roadmap to reach net zero by 2060. How are we going to do that? First, we will not adding any new coal power plant. Aside from the one that is already under pipeline or under constructions. And then the focus of the development of generation capacity in the future will be focused on renewable energy and clean technology. Our emissions will reach the peak by 2030, which is in the level of 335 million tons of CO2, and then we'll gradually reduce until reaching net zero by 2060. We are not only focused on renewable energy, but also other new technology like carbon capture and storage, which I believe already presented by Dr. Cho earlier. And also like hydrogen and ammonia is also something that we would like to explore as a co-firing with coal power plants. So not all coal power plants will be retired. Some of them will be kept in operations, but using cleaner technologies. Next slide. So after having the roadmap of net zero, of course, the most important thing is how we implement the roadmap. So since our announcement in COP26, we have implemented 8 lighthouse initiatives, which is divided into 3 clusters. The first one is how we decarbonize the coal and gas power plant, which is the largest contribution to our emissions. We are not only not adding new coal power plant, but also for the existing coal and gas power plant, we try to reduce its carbon footprint. For example, in the coal power plant, we already implement so-called biomass co-firing in 36 coal power plants throughout Indonesia, which reduce emissions around 800,000 tons of CO2 last year. So this is to enable reducing the carbon intensity in coal power plant. Also in gas power plant, for example, we use the waste house gas from the gas turbine to create or to produce additional electricity. So with the same amount of gas being burned, we have more electricity, which reduce the emission intensity of the electricity produced from our natural gas power plant. And also we already had a pilot of co-firing and co-firing with hydrogen and ammonia. This is still in the pilot phase. Technically, it is still possible. It is possible, but we are still need to work on the economic of these technologies. And then the next cluster is expanding renewable capacity and its supporting system. So we built new additional renewable capacity to meet the additional demand. And also we have piloted several smart grid program in several islands. And then the next part is we also not only decarbonizing the supply chain, the supply of electricity, but also the downstream of the electricity supply. So we also supported the decarbonizations in other sectors like in industry and in transportations by providing electric vehicle ecosystem. We have provided charging station for electric vehicle in many places. And also we produce renewable energy certificate. We also offer green energy as a service for a company who needs electricity, dedicated electricity from renewable energy. Next slide. So if you want to measure emissions, of course, we have to align this with the nationally determined contributions of our country, of Indonesia, which Indonesia has the target to reduce emissions by 2030 by 21.8% or 21.9% by 2030, and 11% from is coming from the power sector. So aligning with this target, we have aligned with the government of Indonesia on how much portion of PLN to be reduced in accordance with NDC, and we have calculated our contributions, which is until December last year is 36 million of emission reduction. This is calculated based on the renewable energy project that has commissioned, and also the waste heat utilizations, and also the use of more efficient coal power plant technologies that could reduce emission compared to business as usual scenario. If we go to the next slide. So in this presentation, I didn't show the amount of capital expenditure required to reach net zero, but actually it is more than 700 billion of 700 billion US dollar until the total investment cost required until 2060, and of course this huge amount of investment needed. Not to mention the increase of electricity costs because of this investment or because of this commitment to net zero. So that's why we cannot do this alone. So we need collaborations, we need partnership with everyone, with businesses, with financial institutions, with governments, with NGOs, with everyone, with every citizens of Indonesia and with the global communities to collaborate together to support Indonesian energy transition effort, especially in the electricity sector. So one of the collaboration could be in supportive policies. For example, we have the plan for retiring coal power plant earlier than it should be, but it cannot be done without any international support in the forms of grants or very low cost financing. So the policy that can support this can also very important to be able to retire coal power plant earlier than the natural economic lifetime. And then, of course, on building people capabilities and competencies, we also need support from the leaders of the technologies around the world on new technologies that we are not having at this time, but we need to have it in the near future to enable our energy transition. And we also need to collaborate on innovation and harness new technology and how we can reduce costs of new technology. For example, I mentioned about hydrogen and ammonia co-firing. This is technically possible, but in terms of cost, it's not economic yet. Also, there is another technology like carbon capture and storage, which is still very costly at this moment. So we need innovation, collaboration to innovate on these new technologies. And then also, of course, in terms of low-cost financing, how can we have support from international communities, from investors, and also lenders to provide us with a very low-cost financing for our green energy or energy transitions program. So this will end my presentations, and thank you very much for your attention.
Thank you, Mrs. Kamia Handayani, for your presentation. Next, let us invite Mr. Ko Jong-soo. He will be speaking on the topic of LNG cold energy utilization for cold chain industry or hydrogen infrastructure technology.
Thank you very much, His Excellencies and distinguished guests. Very good afternoon. Assalamualaikum warahmatullahi wabarakatuh. I'm very honored to present co-gas tech, LNG cold energy utilization, and hydrogen infrastructure technology today. Next, please. And next, please. Next, please. Yes, co-gas tech is a state-owned gas utility company. We are the engineering arm of Korea Gas Corporations under Ministry of Trade, Industry, and Energy. Next, please. Yeah, this is a business area co-gasting is doing, and so we are providing consulting, engineering and procurement, and construction commissioning, and operation maintenance for LNG terminals. Next, please. Yeah, this shows the co-gas is operating in South Korea Peninsula. Co-gas is operating 5 terminals. Now we are doing the construction for the 6th terminal in the western coastal area called Dangjin City. So we are operating in the totally 74 LNG storage tanks, and smallest tank size is 60,000 cubic meter. The biggest one is 270,000 cubic meter, which is operated in the Samcheok LNG terminal. Next, please. This is a global experience, co-gas tech experience. The yellow color is the Middle East. In the middle is the Asian experience, and the right side is Korean experience. Next, please. Yeah, second session is about LNG cold energy. LNG is a colorless and transparent liquid. The boiling point is minus 160 Celsius. So it takes 200 kilocalorie of heat, which is equivalent to 850 kilojoule to transfer 1 kilogram of LNG into 0 Celsius of natural gas. The energy produced in this process is called cold energy. Next, please. When it comes to loop structuring of LNG cold energy, energy paradigm shift in line with decarbonization energy policy encouraged to make more use of low carbon emission energy efficient technology. This global energy policy and creating diversified application encourage industrial players to adopt such technology, which make increasing demand. Also, increasing application with developed technology contributes to create new energy industry. This kind of circulation loop is the driving force to strengthen LNG cold energy industry. Next, please. Yeah, this slide shows the classification of LNG cold energy industry. Energy form of LNG cold energy is temperature or the pressure energy in the first classification. There are three technology fields such as low temperature, and refrigerate generation, and liquefaction in the second classification. There are 9 business applications, normally known as 14 business applications in the world, but we are only consider 9 applications in this slide. The first one is a cold storage. This is a method of supplying cold energy after heat exchange after refrigerant, which is used in refrigerated frozen warehouse. Second, low temperature grinding, which is a method of pulverizing at a low temperature, normally using is the liquid nitrogen for dismantling, sorting, raw material recycle industry. Third, that is district heating, which provides cooling at 0 to 1 Celsius level for steam, hot, cold water, and air condition supply. 4, data center. In data center, we can use the waste heat from the data center, which is used for vaporization of LNG and cold energy. It's used as a coolant. Fifth is used in sports park. When we make an artificial snowflake, we can use this, and also we can use this ice rink, some skis, slopes, something like that. We can use this industry also. 6, cryogenic generation, which is a method using cold energy to recover energy in 2 forms, temperature and pressure. 7, air separation, which is using pressure energy to remove byproducts of air by liquefying and purifying it. 8, the carbon productions. We normally use this as manufacturing carbon dioxide and dry ice. The last one is we can use cold energy for hydrogen liquefaction to liquefy hydrogen using LNG cold energy. Next. Yeah, next. Yeah. This shows LNG cold energy utilization. There is a 2 method is known by direct pipeline or by tank lorry, which is about by direct pipeline. Case 1 is heat exchange natural gas is liquefied and injected into LNG terminal. It's a left circulation with blue color. Right circulation is after the heat exchanger, the red color pipeline shows to keep some frozen stuff in the refrigerated warehouse to keep the temperature is minus 25 to minus 50 Celsius. Case 2, the only difference in case 1 and case 2 is for case 1 is use natural gas, vaporized natural gas, and re-liquefy to the LNG terminal. But case 2, we used this natural gas to vaporize and supply this natural gas to power generation like that. Next, please. Next, yes. This is another method, like I explained, LNG cold energy utilization by tank lorry. Only difference is by pipeline or by tank lorry is the distance where the market is from the LNG terminal. So in this case, we deliver natural LNG by tank lorry. The system is the same as I explained the previous slide. Next, please. Next, please. Next, please. This is the experience what KOGAS did in South Korea. The project name is Pyeongtaek Osung Cryogenic Distribution Center. Our client is Eugene Spurfreeze. Pyeongtaek is where KOGAS energy terminal is located. Osung is the city is well known for the pharmaceutical and biotechnology. You know, Pfizer vaccine that should be kept in some cryogenic conditions, such as minus 70 Celsius like that. So that's why this area is very key locations to keep this cryogenic stuff in the warehouse. So what KOGAS did for the project, we did EPC for this project. Next, please. Yeah, this is the process of this warehouse. There are 4 heat exchangers depending on the temperatures required for each warehouse. There was 3 different frozen warehouse. Next, please. Yeah, this is another project we are executing at this moment in Korea. It's the Incheon Cold Chain Cluster project. Client is the Incheon Port Authority. This location also is chosen because KOGAS has Incheon LNG terminal there. We operate 23 LNG storage tanks in terminal. So by using this cold energy, we can now develop this industry. So our KOGAS role is now we did technical service for detailed design for this. And now KOGAS also shareholder partner for operating this project. This is first one is the by tank lorry delivery. The second one is the by direct pipeline connections. Next, please. Next. Yeah, this is, I found some of cases in overseas. This is what I found in PTT LNG. KOGAS also did design for the PTT LNG storage tanks. PTT LNG, their operating capacity is 5 MTPA. They are using this cold energies for project, like they are using the cryogenic generation, they are using this cold energies reduce the temperature to enhance of turbine efficiency. And also they are using this to replace all the buildings AC system. And last, they also utilize this cold energy for planting, growing the tulip. So future, they are planning to use this cold energy for cool down the data center. Next, please. Yeah, this is another case I found from Japan. Osaka Gas, they are also use the cold energy for their power generation, ACs, and the water chilling system, and enhance the expansion of turbines efficiency, and air, liquid, and separation. And also they are using this cold energy for the ethylene plant to cool down of some of the materials from the byproduct of petrochemical. Next, please. Yeah, that is the benefits of cold energy utilizations. Next. Yeah, about the hydrogen, this is hydrogen value chain. Next, please. Yeah, what KOGAS is involved in the hydrogen industry, we are involved in hydrogen production and hydrogen utilization. For example, we involved in some of hydrogen refueling station, EPC, and operation maintenance project. Next, please. Yeah, this is what KOGAS' capability about hydrogen business. First one, we are involved hydrogen production basis. We already completed the 4 projects for Pyeongtaek and Busan, Wonju. That is our gray hydrogen project. We produce the blue hydrogen. The last one is project for Gangwon. This is a green hydrogen project. And second one, we complete the 50 hydrogen refueling station in Korea. And also we have a good technology for the CCUS. And also we are involving in the power to gas project in South Korea. This is one project we are having in the UAE. I'd like to introduce this briefly. This is a project for using the hydrogen, green hydrogen, and refuel the hydrogen mobility in the Abu Dhabi in UAE. So KOGAS Tech's role is the leader of the consortium. We are working with the DMT, the Department of Municipality and Transport in South Abu Dhabi government. Our role is to make a system for, from the ESS system, and we are developing of the 2 different type of electrolyzers, alkaline electrolysis and the PEM electrolysis. This concept is an on-site concept, means green hydrogen production and the refueling station in the same site. That is an on-site system. Yeah, next please. Yeah, so that's this is a red box. It shows where KOGAS Tech is involved, active in for the decarbonization policy. So hopefully we can do some similar kind of concept project in Indonesia in the future. Thank you very much.
Thank you so much, Mr. Ko Jung-soo. Now let us invite Mr. Surya Triharto. He will be speaking on the topic of corporate energy transition strategy, challenge, and opportunity. Ladies and gentlemen, please give him a round of applause.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Excellencies, distinguished guests, and ladies and gentlemen, it's an honor for me to be in front of you all to deliver some information regarding the corporate energy transition, challenges, strategy, and opportunities at Pertamina International Shipping. As you may aware, Pertamina International Shipping is a subholding of PT Pertamina Persero. Our business encompasses integrated marine logistics. Simply, I can say our business is from terminal to terminal. So, for whatever product need to be transported from one point to another point, selling on the sea. So these are our core business. So we are not just to avoidance of doubt, we are not only transporting the product, but we also store the products to terminals. We have also several terminals in our portfolios, and so we also have port on logistic services as interface between the sea and the land supply chain of the products. Now our business is primarily is the petroleum core, but we are moving forward to expand our business out of the petroleum core. We'll maintain our petroleum core, but we'll expand our business not only for the fluid products, but also for dry bulks and also probably the container. So our aspiration to become Asia Leading's integrated marine logistic company to serve the customer. Next, please. Next, please. There's only a short information about me myself. My name is Surya Triharto. I am now in charge for the title of Director of Human Capital and Corporate Service of the Pertamina International Shipping. Let me start this session with a provocative question about where and why would you invest $1 billion for the best return in sustainable shipping? So we got some, you can say, anecdotal answer from the practitioners and professionals in the shipping and marine logistic industry. Even though, although this answer sounds anecdotal, but I strongly believe that the answers was based on their knowledge, skill, and experience in this industry. So we can see that how then answer that they will invest in taking efficient roads, keeping vessels hull smooth, renewable biofuels, wind-assisted propulsion pilot project, and futuristic fuels such as hydrogen and synthetic biofuels. All are related with the emission reduction, as you may aware. Also, some practitioners also answer for the purpose of investment in betting the single fuel to be more aware about alternative fuels in order to provide options for the players in the integrated marine logistic industry with more optimized in their fuel costs. As you may aware, also just like the industry of aviation and transportation, fuel consumption is the most important contribution in the cost structure. And also, you will see also some answer about intention to invest in the hydrogen fuels, biofuels, and carbon capture. You will also see answer there about the investment in flexible, scalable, and cost-efficient CO2 carriers with the ability to inject CO2 directly into the storage facilities offshore. So, as the communities in this industry, we may aware that all of the answers are now in the progression of the transition energy in the world, not only in Indonesia. So, what does it mean for us in the communities of this industry? It means that we need to consider the option of this $1 billion investment, although it's just as a provocative question for all of us. Next, please. Thank you. So, we also understand that although to be compared with the road transportation, contribution of the CO2 emission of the shipping industry is not significant in terms of to be compared with all of the CO2 emission from the transportation, but it still contribute 3% in the world. And by which then I must still, next please, I must still have a strong ambition to reduce this emission. IMO has already implied the restriction to reduce the CO2 emission. We using 2008 as a baseline. The ambition is to reduce up to the 60% lower. And in the 2050 will be 15% lower. And this is the strong ambition for net zero in 2100. However, they still need to be buy-in by us in this industry. Next, please. Next, please. Okay. So not only IMO is International Maritime Organization that imposed that restriction, but also the capital markets, as you may aware, also has already required and have a preference to invest in most favorable green assets in their portfolios. And also we need to make aware also, not only the direct customer of the shipping industry require also the CO2 emission reduction, even the end consumer of the shipping services. Just like you can see out there that H&M and Levi's is a clothing industry, but they also require for their supply chain suppliers to comply with the net zero emissions or CO2 emission reduction in their business relationships. And competitive pressure then push the players of the shipping industry to consider the requirement of the customer, not only the direct customer, but also the end user of the consumer of the product and services provided by this industry. Next, please. But we need to understand also the adoption of low carbon fuels will be bought in only as long as the low end cost doesn't implicate to the customer willingness to pay. So there will be a borders of the customer willingness to pay. As long as the cost still can be absorbed by the end customer or end consumer, so that doesn't exceed their willingness to pay, the carbon fuels initiative will be bought in. So we need to take care of this. Next, please. However, in the shipping industry, is one of the hardest industry in terms of abatement of CO2, including the cost, not only the volume, but also the cost. Next, please. So what we are doing now in Pertamina International Shipping in order to support and buy in with the program to IMO to reduce CO2 emission. Number one, we do the decarbonization of our business. So since the last year and until the midterm, let's say 2030, we have existing initiative to implement ship speed management and road optimization to abate 20 kilotons of CO2 a year. Last year, we have already recorded 11 kilotons of CO2 abatement. I'm not so sure has it already been audited yet, but that is our figure last year, 11 tons of CO2 abatement last year. And we also apply efficiency levers to the operation of our fleets using the windows of docking period of our ships by implementing the engine derating, hull point coating, hull cleaning, propeller refitting, and improvement devices, proper and trim and rough optimization. You know that all of the duties are intended to optimize the speed of vessel during during the sea time, because all of those are important factor in maintaining the optimization efficiency of the ship operation. In the long run, we have a long-term plan or position to renew our 200 fleets, not only owned and operated by us, but also the fleet that we chartered to comply with the dual fuel initiative. It can be fuel oil and LNG, LNG and ammonia, fuel oil and methanol, and other option of dual fuel to improve the fuel efficiency. And hopefully, in the long run, we move forward to fully carbon fuel for the ships. We also seeking the opportunities in the future for the new business, such as the hydrogen. I'm glad to see that Kogas has already had the cluster of hydrogen business in several countries, not only in the Korea, but also in UAE, I saw before, from the presentation of Mr. Ko. This is one of our medium-term aspiration to prepare fleets for ammonia shipping for export market, at which then we need to have the molecules of hydrogen and also the supply chain of the hydrogen itself. In the long run, we will expand our fleets for liquid H2 shipping post-2040 for export market. As you may aware now, we are not only serving the domestic market of Indonesia, but we are also serving international market. It means that our ships not only sailing inside and in out of Indonesia as the cabotage principles, but also our fleets sailing over country to country outside of Indonesia. So another new business initiative we are seeking in the future also is carbon capture storage and carbon capture utilization storage. In the shipping industry, we have not had the record so far, but in Pertamina there is already the first initiative that is inject the carbon in one of the locations of Pertamina, but I think there is another person that authorized to deliver this information to this forum. But for us in the long future, in the medium term to the long run, we are seeking to grab the opportunities of having business of CCRS. Not only for the transportation of the carbon itself from the center of production of the carbon, but also to develop the storage for the purpose of the usage of the customer, whatever they need to use, whether to inject it into the air again, or to help to improve the production and national recovery in some areas, not only Indonesia but also all over the world. So that's what I mean for us, the imposition of the regulation by IMO, regardless only 22.4% or 2.8% contribution of the shipping industry to the CO2 emission in the world. Next, please. This is a little bit more detail about our aspiration and our program in the short term, medium term, long term. Sorry for a little bit exceed the time, but I need to inform you this last slide about the fleet age. We have aspiration to reduce the average age of our fleet age. That means have contribution to the CO2 emission also. Green operation, we have been starting since the last 2 years to impose the green operation, not only to our fleet, but also to charter fleet we used to deliver service to our customers. Green cargo, we also now focus on the cargoes that support the energy transition, and also green port. Green port, we manage several ports directly owned and operated by us, and we have been starting to develop a system of operation and requirement in at the port to reduce CO2 emission during the operation of the port. And also the last is the green storage. As you may be aware, and I informed previously that our business is encompassing the terminal to terminal and sea transports. The green storage is one of also our concern in the next future. Next. So the last one is there are several opportunities in relation with the reducing emission which means the declining of the consumption of fossil fuel. Chemicals will be the potential of transportation exchanging with the fuel. Electric vehicles, there is also opportunities to grab the potential of transportation of battery in supply chain all over the world. Hydrogen, also not only for usage of our business as well, but also transportation. Biofuel, also the transportation, and storage, power, and also CCUS and CCS. These are all the opportunities now. We would like to invite all of the participants here, all of the communities in this business during this transition energy. Regardless, fossil fuel is still the most viable economically as energy, but the transition need to be moved forward to become more interesting and in order to provide customer with more option of the fuel. So let's work together on this. We are most welcome to work together, having partnership discussion to figure out to overcome challenge and to grab opportunities in the era of this transition industry. Thank you.
Thank you, Mr. Surya Triharto. You may return to your seat. Ladies and gentlemen, our next speaker is Mr. Kim Ki-dong. Unfortunately, he could not attend the conference. He would like to present his topic for today through a recording under the topic of SSLNG and blue hydrogen using cold energy of LNG for South Korea and Indonesia. Let us welcome Mr. Kim Ki-dong in video.
A small-scale LNG and blue hydrogen using cold energy of LNG for South Korea and Indonesia. My presentation will begin with an introduction to the Korean government's net zero policy. The South Korean government has declared to the international community that it will achieve carbon neutrality by 2050. In 2021, the Carbon Neutrality Act was enacted, making it a legal requirement to implement this policy. It has created a net zero scenario, and carbon reduction in energy is the most important issue in this scenario. In the energy sector, it is important to reduce greenhouse gas emissions from power generation. And in South Korea, fuel cell power plants have increased due to government support. However, fuel cell power generation currently uses natural gas, and that means gray hydrogen-based fuel cell power plant, which emits CO2 and very low contributor to greenhouse gas reduction. To improve this, the government wanted to introduce a clean hydrogen certification system from 2023 October. The government also wanted to make and use clean hydrogen mandatory for hydrogen power generation to reduce greenhouse gas emission. The LNG and hydrogen industry in South Korea is briefly represented in this slide. LNG is distributed through wholesale and retail business, and fuel cell power generation operator are the end user and are currently developing gray hydrogen power. The end consumer pay the sum of wholesale and retail supply cost as the final fuel price. Meanwhile, hydrogen is produced as a byproduct at the refinery and delivery to a refueling station via tube trailer. Another way to produce hydrogen is to receive natural gas from retailer and use a steam reforming reaction to produce hydrogen, which is then supplied to hydrogen station. All of those hydrogen supplies are gray hydrogen, and the price of fuel is also high due to wholesale price plus retail supply. The Korean shipbuilding industry have been ordered 167 eco-friendly ships in 2022 with a 54% market share in the world. In the process of building LNG ships, one of the last stage of ship construction is the gas trial process, where LNG fuel is supplied and tested. Currently, the LNG required for the gas trial process is 200,000 tons per year for LNG fuel the ship from Korean shipyard. The reason why small-scale LNG and blue hydrogen are needed in South Korea are as follows. The Korean fuel cell power generation company wants gas at a lower gas price than current retail price, especially a process to make blue hydrogen. A fuel cell power company wants to link with refrigerated warehouse business using LNG cold energy. The Korean shipyard wants to test run LNG ship with a reasonable price natural gas through small-scale LNG. It also hopes to discover business related to small-scale LNG and liquid carbon dioxide as a new business. Let me explain hydrogen production and CO2 emission from small-scale LNG. LNG is regasified into natural gas, and natural gas is supplied through the reforming process. After reforming process, hydrogen is produced through a water-gas shift reaction and a PSA process. The hydrogen produced in this way is applied to the fuel cell power plant, and 70 or 20 more percent carbon dioxide is emitted from this reforming reaction. Manufacturing 220 tons of hydrogen in a small-scale LNG system require 800 tons of LNG and emits 2,100 tons of carbon dioxide. CCS system is required at the rear end of a burner to turn this gray hydrogen into blue hydrogen. This slide shows the CCS and LNG cold hybrid system. For carbon dioxide enhanced oil recovery, EOR, a purity level of 95-96% is required for carbon dioxide. The proposed carbon capture and storage system will produce two types of liquefied carbon dioxide. High purity carbon dioxide with a purity level of 99.9% and low purity liquefied carbon dioxide with a purity level of 95%. Both type of liquefied carbon dioxide will be cooled using LNG cold energy supplied to reach different pressure and temperature condition. The high purity liquefied carbon dioxide will be cooled to around 9 degrees Celsius at 40 bar, while the low purity liquefied carbon dioxide will be cooled to -9 degrees Celsius at 30 bar. I would like to propose a business model that links small-scale energy and blue hydrogen needed in South Korea with LNG imported from Indonesia. This is a business proposal that links industrial liquefied carbon dioxide imports and small-scale energy exports from Indonesia with what is needed in South Korea. Since it is a small business, a large LNG terminal is not required, and most of them are transported by ISO tanker container and container ships. Let me conclude my presentation. Korea's some energy sector needs small-scale energy and blue hydrogen. The clean hydrogen portfolio standard, also called CHPS, will be introduced to hydrogen power generation in this year in South Korea. There are some issues in hydrogen power generation and shipbuilding company in South Korea. I propose a new business model for mutual benefits in the energy and industry sector of both Korea and Indonesia. I believe that the small-scale energy and blue hydrogen with CCS can be successful in cooperation in both countries. Thank you for your attention. 감사합니다.
Thank you so much. Thank you all speakers for the third and the last session. Before we wrap the last session, let us have a short Q&A session. So if the audience have questions to the speakers on their presentations, please raise your hand and we will deliver a microphone for you. Can we have a microphone for the gentleman on the seat A, please?
Thank you for your presentation, especially Mr. Go. I have lots of interesting regarding the cold energy utilization. Almost you just explained 9 sectors, but especially today, I have a question regarding the cold storage sector. My question is Kogastek has an actual track record of cold storage utilized by LNG cold energy currently? If you have already, please could you introduce about specific number of RT capacity as well as a type of refrigerant and process, just a brief process explanation between cold storage and heat exchanger. Thank you.
Thank you.
Actually, sorry for that. I don't remember the specification numbers, but we have some specific presentation of this cold energy which we did in the Pyeongtaek LNG terminal. So I think I can provide this material to you after finish this this session, and that will be useful for you to understand some technical aspects of our warehouse sizing and type of the refrigerant. Yeah, that kind of information will be provided to you. Okay.
Thank you very much. I'm Jong Ok from Gas and Tech Korea.
Okay, I will right away come to you after
Thank
this
you, thank
session.
you.
Okay, all right. Thank you.
Thank you so much. Do we have any more questions? Please raise your hand. Yes.
Yeah. Good afternoon. My name is Danu from Pertamina Gas. I have two questions for Mr. Pope from Kogastek. Very interesting presentation, sir. Currently, Pertagas conducting conceptual study of LNG cold energy utilization integrated with air separation, cold storage, and LAES, liquid air energy storage. And we also have our own LNG terminal, so there is opportunity to develop this LNG cold energy integration. My question is quite similar with the previous question. The first question is, what is the minimum capacity of cold storage that feasible to be integrated with LNG cold energy, and how much LNG is needed to provide the cold energy? And could this system apply to existing cold storage with conventional refrigeration system? And the second question is regarding to your presentation of power generation using LNG cold energy. What is the minimum power capacity to be produced is feasible to be integrated with LNG cold energy, and how much LNG is required to provide the cold energy? Thank you.
Thank you.
I don't know whether I fully understood your questions. That is about technical question, right?
Yeah, the minimum capacity for the cold storage can be integrated with the LNG cold energy utilization.
There's no limitation of the limitations. We don't consider any limitation of the minimum capacity, because in case of the PTT LNG, there were 4 projects in phase 1, phase 2, phase 3, phase 4. Okay. So phase 1 is start with application of cryogenic power generation purpose. That is 22 megawatt power generation purpose, and then they are extend their applications. Second project is to use to cool down of air inlet of to providing the gases to the turbine to enhance their efficiency of the turbine operations. And third one is they are used to change their building applications, and they extend more cold energies. And fourth one is also they are used 3 megawatt of cold energy for planting of the tulips. Yeah, something like that. There's no limitation. Maybe if you have specific requirements for your considerations of this concept, we can discuss about it.
Okay.
Is it okay?
Yeah, okay.
Enough for you, right?
Yeah. So for as your reference, 20 megawatt is a good start to develop this LNG cold energy integration. Yeah. And yeah, there is a requirement in our company also for the power generation, and it might be could be integrated with the LNG cold energy.
Yeah, we are ready to propose. The Arun energy terminal. We know Pertamina Gas has Arun energy gas terminal. So with this energy terminal, we can provide some proposals to how to. I don't know your requirements, but depending on your requirements, we are consider and discussion on this subject with your company. Okay.
Okay. Thank you.
All right. Thank you.
Thank you so much. Do we have any more questions from the audience? Please raise your hand. No more? Okay, so as there are no more questions from the audience, let us finish our last session. Ladies and gentlemen, please give our speakers another big round of applause. Thank you so much. You may now return to your seats. All right, ladies and gentlemen, I believe our discussions today have been constructive and abundant. Through all that we have shared and learned today, I hope that these seeds of knowledge can be planted and that it can grow and blossom into a much more sustainable and beneficial offshore industry that we can all reap from. The opportunities provided today by participating companies will open new innovations and roads that we all can take part in. With this, I hope that we can each form a vision on how we can get involved in forming a more sustainable and effective offshore industry. Today's events will not have been possible without the participation and support to all parties, speakers, and participants present here in this hall. For that, the host, event staff, and I are highly grateful for your patience and time. I am Leah Atmajaya, your MC for the 3rd Korea-Indonesia Offshore Congress. Good evening and have a good night. 감사합니다, 여러분. 안녕하세요.